Welcome back to Maths with Mrs. J. In our previous video, we introduced the idea of Venn diagrams as a really good visual way of representing information. This often comes into play in situations where you're talking about a group of people playing two different sports and who plays both, who plays neither, that sort of thing, or learning a musical instrument or studying a certain subject or liking a certain dessert or whatever the case may be. It could even be used for a situation like having pets. Who has a cat? Who has a dog? Who has both? That sort of thing. In our previous video, we ended with this example where we had a school with 90 students in year 10. We were told that 60 played football, 55 played basketball, and 10 played neither. And we were able to work out that the intersection, or those who played both, must have been 35, because otherwise, if you add up football, basketball, and your neither, you get 35 more than your total number of students. Now, another fantastic way to represent this information is in what's called a two-way table. You put one of your categories along here, and you're either in that category or not in that category, so basketball or not basketball, and your other category goes here, so either football or not football. Let me help you understand how this table works and show you how to fill in the information. Okay, what's going to go here will be the number of people who do both football and basketball. And we know from our working out that that's 35 people. What's going to go here? Well, this corresponds with not basketball and not football. So that's going to be these 10 people who play neither. Now, how am I going to work out these other two bits? Okay, the one that's going to go in here is going to be people who play football but don't play basketball. So they play football, but they're not in that intersection group. So that's this 25 people here. Now, just to check, 35 plus your 25 does equal your total who play football. So that's a great check there. What's going to go in here will be those people who play basketball but not football. So they play basketball, but they don't play football. So it'll be these people here. And again, our 35 plus our 20 should give us our total number for basketball. Our total number for not playing football should be 30. Our total number for not playing basketball should be 35. And both those numbers should add up to our total, as should both of those. So it's a really good little check just to make sure that you're on the right track and that everything's adding up correctly. Okay, so we're going to do an example here. Similar sort of situation. In this case, we want to get practice at doing both. So we're going to do a Venn diagram and a two-way table. And in this case, we have 200 students at the high school. And we're talking about studying maths, studying science, studying perhaps both of them, and studying neither. Let's maybe start off with our Venn diagram. So we have our total number of students. So that's our universal set. Let's call this one here maths and this one science. Okay, now the total number of students that study maths is 150. Let's just write that down. There's 150 in total. Science has 120 in total. It says 20 students study neither. All right, so where do we put our 20? We put our 20 somewhere that's not inside those circles. Now, before we can actually fill in these circles, we need to work out what the overlap is going to be. We know that we have a total number of students of 200. Our 200 students must equal this number plus this number plus this number plus this number. Now, what are we going to do here? How to work out the overlap? We're going to do 200 minus 20, which is 180, right? And then we're going to work out 150 and 120 is 270. Well, our 270 minus our 180 must have been our overlap. 90 students must do both because of the totals. Let me just go through that again. We've got 200 students in total. If we were to just add up the number doing maths, the number doing science, and the number doing neither, we'd get 270 plus 20, which is 290. But we've only got 200 students. So that 90 extra must have been these students who were counted twice. So that's the overlap there. How do we work out what's going to go here? Well, here will be those who do maths, but not science. So there is a total of 150 in here. So what must this number be? It will be 150 minus 90, which is 60. What's this number going to be? Well, our total for science is 120. 90 of them are already accounted for. 120 minus 90 gives us our 30 here. Now, just to check, 60 plus 90 is 150, plus 30 is 180, plus 20 is our 200. Always, those 4 categories have to add up to your total. Whatever in excess of your total you have will tell you what must have been counted twice and therefore what is in your overlap. So how do we do this in a two-way table? Doesn't matter whether you choose to pick, put your maths and not maths here or here. So we might as well do maths and no maths, science and no science. Okay, all right, so it's fairly easy. If you've got a Venn diagram, to go from a Venn diagram to a table is actually really easy. The 20 is going to go in the no maths, no science, because that's in the neither category. This 90 is going to go in for both. Maths but not science will be this 60. Science but not maths will be this 30. And just let's check our totals. 120 for science. Yes, that's correct. Excellent. 90 plus 60 for maths, which is our 150 for maths. Great. If we add up these other numbers here, that's 50 across, 80 across. And if we add down and across, we get our 200, which is our overall total. So we've got it all under control there, all adding up to the correct thing. Just remember your intersection, this bit here, the people who do both will be the amount over the total that your numbers add up to. Okay, probability that the person studies maths. Just a person at random out of these 200 people. Well, our total number who do maths is 150 and we have 200 students, and that just simplifies to 3/4. Probability that they do maths and not science. So we could do that as I'll talk about complement in a minute, but not science we can write like that. So maths but not science is these people here. So it's 60 out of our 200, which is what? 3/10. Doing both maths and science, we could write as the intersection of maths and science. That's these people in the middle here, or these people here. That's 90 over your 200, which is 9 on 20. Now, these are called conditional probabilities. Let's just think about this really carefully for a minute. So we're talking here about the probability that a student studies science, given that you know they study maths. So what you're actually required to do here is to only consider the people studying maths. And out of those, what is the probability that the person studies science? So it would be 90 over the total for maths, which is 150. So probability, and we write it like this, science given maths is going to be our 90 over our 150, which is 3/5. So just saying that again, if you are told that the person studies maths, you then basically are only considering that part of your situation. So your maths total becomes your denominator and the number that do both becomes your numerator. Okay, similarly, in this case, we're just concerned with the people studying science and we want to know what's the probability that someone studies maths given that they study science. Well, the number who study science is 120 and the number of those who do maths is 90. So that's 3/4. All right, that's starting to get a little bit more tricky there. I wouldn't worry too much about the conditional ones just yet because we will get into that in more detail. But if you can have a good understanding of your Venn diagrams and your two-way tables, that would be fantastic.